Hi, my name is Begoña Arellano Jaimerena, and I am one of the advisors working on the Water, Peace and Security Partnership. In this video, I will give you an overview of our work about the water resource system and the hydrological analysis. To have good insight into the behavior of the water resources system under different circumstances, we can develop a water resources model. Such a model allows the user to make simulations of the water resources system under different external scenarios, such as a change in water availability due to climate change. But it also allows us to simulate different measures or sets of measures grouped into strategies to examine the impact of changes in the basin. Normally, we start with simulating a base case, which is a simulation of the present situation. Then we can simulate future time conditions, time horizons. For example, with scenarios of climate change, population growth, or industrial development. A bottleneck analysis allows to find under which conditions problems can be identified, often in terms of regular shortages of water or other unwanted critical situations in the basin. This analysis helps to formulate measures that are expected to mitigate the negative impacts. Such measures are often grouped into strategies and applied in combination. By carrying out large numbers of simulations with different configurations of measures and strategies, we can assess the strength of the solution. By varying the external conditions and the configuration of the measures, we can assess the robustness of the measures and/or the strategies, or, in other words, which ones are the strongest under a range of different conditions. The simulation of the water resources system includes a combination of the hydrological cycle and the man-made interventions. However, a distinction should be made between the natural system and the unnatural system, the latter representing that part of the water cycle that has a noticeable influence by humans. There is not a sharp distinction between the two, but in general, the models that are used to represent the water resources system start at those locations where, for example, a major water intake or a surface water reservoir is present. In essence, the water resources model has three main components. The first one is the water availability. The second one, the water demands, for example, public water supply or hydropower. And the third one is control, for example, pumping stations or water intake. Water availability is always present and normally is a combination of surface water and groundwater. However, the absence of either water demand sectors or control in the system makes a water resources model superfluous. Mind that in water demand sectors, a distinction can be made between the water that is consumed and the one that is not. For example, part of the water that is consumed returns to the system as wastewater or return flow from irrigation or agriculture. The water that is not consumed refers to the sectors as hydropower and environmental flows, where the water is used but stays in the system. For the water availability of the surface water, a simulation of the natural water system is required. This refers to the part of the water cycle that is above any human-made disturbance. We use hydrological models or rainfall runoff models, which provide the input for the water resources model and to define the boundary conditions. Like with other models, for the development of a water resources model, it is necessary to find a way to represent the natural reality in a model environment. For this purpose, the water system is represented in a schematization that includes the various items found in the natural system, such as rivers, canals, and reservoirs, to name a few. Surface water and groundwater are connected parts of the water system. However, sometimes the priority is on one of them only. If we include groundwater in the model, we need to pay special attention on how to represent it and how to include the connection with surface water.